direction of the wrench can be oriented along the positive y-axis and it grips a bolt at the origin. A force is applied in the direction of 0, 3, -4 at the end of the wrench. Find the magnitude of the force needed to supply 100 Newton meters. Okay, so torque is work.
We have torque.
Because its units are, so it's energy. Torque is energy, because its units are Newton meters. Which, yeah, that makes sense, because your displacement is in meters and your force is in newtons, so you're going to Newton meters. So on the last problem we just did, our 10.64, whatever, the unit should be Newton meters. All right, so drawing a picture so we can kind of see what's going on. We've got a bolt at the origin. There's a wrench gripping it, and it can be oriented along the positive y-axis, and it's 0.3 meters long. And our force is being applied in the direction of 0, 3, -4. That's going to be a little hard for me to draw. So I 0, 3, -4. So
towards us would be positive z, right? And towards into the board would be negative.
Well, yeah, hang on. I might just redraw it so I can tell. Okay, I'm going to make that y and that x, and then here's positive z and there's negative z. So here's my bolt. My wrench is 0.3 meters in that direction, and then 0, 3, -4. So there's a force going in the direction of 0, 3, -4. All right. Well, here's a good little review problem. We're going to answer their question. Find the magnitude of the force needed to supply 100 Newton meters of torque to the bolt. So the 100 Newton meters is the magnitude of the torque. Okay, so the magnitude of the torque is 100 Newton meters. We learned that you could find that by finding your R and finding your F and crossing them and then finding the magnitude, or it's equivalent to the magnitude of the displacement, the magnitude of the force, times sine of the angle in between. So I need the sine of the angle in between. So here's a good little review of how I would find the angle in between these two vectors. So remember, cosine of the angle in between would be their dot product divided by their two magnitudes. So my one vector is 0, 3, -4. That's my force vector. The displacement vector is pointing straight up the y-axis, so it's 0.3, 0. The magnitude of this vector is the square root of 0 plus 9 plus 16, or in other words, what's the square root of 0 plus 9 plus 16?
5.
5. And without doing any work, what's the magnitude of that vector?
3.
0.3. Okay, so let's kind of figure this out. I'm going to get 3 times 0.3, which would be 0.9, right? Otherwise, I'm going to get 0 and 0. And then the bottom, I get 5 times 0.3, which should be 1.5. So inverse cosine of 0.9 divided by 1.5 is my angle. So sine of that angle would be sine of inverse cosine of 0.9 over 1.5. So if you're trying to keep things exact, you could type that whole thing in your calculator.
didn't you do the square root of 0.3?
Well, it really would have been 0 squared plus 0.3 squared plus 0 squared, which would have been the square root of 0.3 squared, which would be.
Oh, okay.
I understand you don't play the Pokemon game, but you gotta know the value when you see it.
So when
People are paying $100
when you only have one component, the length of your vector is that value.
That's a little high.
Yeah, no.
Okay, so
You
I
don't
am
know.
getting sine of the angle to be exactly 0.8, okay? So this is 0.3 meters, we're looking for the force. Sine of theta is 0.8, and we want that equal to 100. So the magnitude of the force is 100 divided by 0.3 times 0.8 is 0.24.